date, time, and we'll also talk about the um, how to work with date time object. Then we talk about the pivot table as well, and the what's it called?
Okay. Thank you, Mr. Ojani. So basically, this is what it is called, how to filter your data, to subset your data. So this is where we had issue the other time. So I tried to figure it out after the class. Then how to subset your data. Maybe you need a subset of your data frame. Then how to group your data. Maybe you want to group it by a particular condition. Then pivot table. Then working with time frame. Time frame, date time is very, very important, most especially when you are dealing with time series data that occur over a period of time. Then how to write your file to a CSV file. And I told you can also write to other formats. You can write to Excel, you can write to JSON, you can write to HTML file. Then today we'll be talking about the place we were trying to figure out last week, that is subsets with multiple conditions. Then how to rename a value within the condition, and how to rename the column. So today we'll be making use of the student data we've been using to get the data set. We talked about it in our last class. So I will still be going over it again now. You can see this GitHub repository, right?
Yes.
So you will go to the folder here where we have data. You click on the data folder. Then there are two data sets here. The first one is the one we've started with the one without missing values. The second one is the one when I removed some of the values to make us have missing values. I believe you understand what I'm talking about.
Yes.
So the one without one is the normal data without missing value. The one with one here is the one with the missing value. So we'll be making use of the one without the missing values. So this is the data to download the data, to use the data in another Python file. Just click on raw. There are two things you can do here. Either you download it straight to your system, or you just copy the link here. What I'm doing, I will just copy the link from here, Control C, and I have the link here. This is it. Just paste the link here. Control V. So I have the link now. Then I'm going to make sure I import NumPy and Pandas. So in the data, there is no the total column is done here. The last column we have here is intelligence. So I'm defining a new column now. The new column is df total. Then what I want is I want it to give me the sum of these 5 subjects. Then the axis is along the rows. So that's why I have this sum here. Then to subset, the mistake I did last week is I was using this and instead of this sign, the ampersand. I don't know the name of this sign. Can anyone help us with the name? This sign, something.
Ampersand.
Exactly, ampersand. So this I was using this and instead of this sign. So the normal sign to use for combining is this ampersand. You use this as and. It is telling you what we are doing is want to subset the data. You can break it down. Let's try to break it down. This is DF, then those that are female. Where we have gender as female. This is it. Then we want to subset for the whole data frame. Then we put the DF at the back here. We can see all these gender, all of them are female. So this is one condition. Then the other condition is where total is greater than 300. So we try to combine the two. So it will give us the data sets where those conditions, the two of them are true. So let's run the code and see. So we can see now we have the condition whereby we have female as gender, then we have total score greater than or equals to 300. So another thing we can do, we can make use of or instead of and. We make use of or, we change this ampersand to this straight sign. What is the name of the sign again? Anyone? Who can help us with the name of this? Just a straight line, sir. This straight line. So this is all condition. It is telling us that if the gender is female, or if the total score is greater than 300. This one is less restrictive as this. This one will make sure that this both condition on the right and the on the left, the two of them are satisfied, then give us the data frame. But this one, once any of the condition, either the one on the right or the left is satisfied, it will give us the data frame. So here we can have gender female, and we can have score less than 300, and we can have gender as male, then we have score greater than or less than 300. So another thing we can do is we can rename our gender. For example, we can rename the values we have here. We have male and female. For example, when you are dealing with machine learning, if you input this male and female into your model, it is going to give an error because machine learning, the computer doesn't understand all these strings. So you need to convert it to number. What you can do is to do df, because you're saying as in the gender column, then replace, what are we replacing? You replace male with this a dictionary with 0, then female, we replace it with 1. Let's run the code and see. We can see we have 1, 0, and 1. So I'm not going to do it. And since we are not dealing with machine learning algorithm, I will just change it to lowercase male. Then I'll make sure I put it in quotation. Then female, I'm using lowercase for female as well. So then I need to use in place. In place, I talked about the function of in place. In place is this. For example, if I run this code, it has changed to lowercase, right? Hello?
Yeah.
It has changed to lowercase.
Yes, we can see it. That's true.
But if I check the data frame, I'm still going to have the uppercase there. You can see we still have uppercase for male, uppercase for female. So what I can do here, I do either of the two things. Either I say in place equals to true. In place is mean I'm replacing it with this new one in the original data set. Or if I don't want to use the in place, another thing I can do is to reassign the value, the df gender. I will reassign it that whatever I have there before, I want to change it to the new values I have. So what I will do is df gender is equal to df gender dot replace. Then I can now check my df. You see the df now, it has changed the male from the gender from upper string to lower string. Do you understand that part? Hello?
Yes.
Do you understand that part?
Yes, we did.
So the next thing is let's try to rename our column. Let's first check the columns we have. df.columns. Then we have this first name, last name. Then I'll be changing each one of them to lowercase. Then I'll be deleting the space we have in between them. What I do is df.rename. Then what I want to rename is column. Then I'm making use of dictionary again. So the new value will be first name but uppercase, but lowercase. Then there won't be any space between the first and the name. First name and comma. Then let me do it for each and every one of them. So for the last name, the value will now be last name, last underscore name. And for gender, we have lowercase gender. And for math, we have my math. Then I'm going to add S because we don't have S there before. Then English. Then biology. Oh. Gender will be gender. Then math will be, the new name for math will be math. It's S. And the new name for English will be the lowercase English. And I can just break this into the next line. Then for biology, we have the lowercase biology. Then the same thing for economics. And to be in string, then agric. Then intelligence. This was wrongly spelled before, so we are writing the correct spelling now, intelligence. I believe that's the correct spelling.
Yes.
So what I did here, previously I did DF gender, then I renamed the gender. What I'm going to do here, I'm going to make use of the in place here. In place equals to true. So I'm going to run the code. So let's check the data frame now, the DF. Can we see that all the names, all the columns have been renamed, all of them?
Yes.
So that's
But
also
I
renamed.
have a question here, please.
Okay.
My first question is like, is it possible to use? Is there any way we can use title for this kind of in this type of
Title case.
yeah, this particular function here?
It's very possible. It's possible. And there's a smarter way to do it. What I did was like it's very like it's not as easy. There's a smart way of doing it. You just say for column in df dot columns. Then col equals to col dot title.
So that's what I'm trying to ask.
This we do. So let's check our df now. Okay, it's not effective yet. For column in df dot columns. Col. Okay, I don't think we need to put col dot title. df col also col dot title. Oh, it changes all what we have inside of this. For column in df dot column col dot title. Let me first try and rectify this. I need to run the code from the beginning. From where okay, let's start from here. Let's first print it to be sure that it is giving us what we need.
Hello.
Hello?
Maybe they're having issues with his network.
I think I'm expressing the same thing. It should be from his side, not the network.
Okay, maybe we should just wait a little bit for him.
Hello, can you hear me?
Yes.
Hello.
Yes,
Oh,
we
I'm
can.
sorry, I have issue with my network. So I'm going to reconnect now. So we are trying to change the columns. df dot columns. Then we print the column here. Then we want to change it to df call equals to call dot title and print call. So we have it now.
Boss, I'm not seeing
Yes,
your
I can see
screen.
your screen. Okay.
Oh, sorry. Can you see it now?
No, not yet. Yes.
So what I tried to do, I tried to convert it to title case, then I print it to make sure that I have it in title case. So I have it in title case, I can delete the print statement. Then for column in df.column, each column should be converted to title case. Then I do it that way. Let's check the data frame now. It is still not converted. Okay. Now change df dot columns equals to df dot code. We have those columns. So we still have them in the normal case. That's title. Okay, I think this is smarter. Let's not wait for that. We can just be doing something else. But there's a smarter way to do it by using a for loop. We can go back to it maybe before the end of the class. So to group by gender, since we changed the gender column to lowercase, then we are going to make use of the lowercase a. Then we check. By default, if you run this, you are not going to see anything. But if you return a group by object, then we can make use of the total column. Then dot mean. You can see the first thing we make a group by object with this. Then out of the object is like a data frame. Then we ask for the total column. Then in the total column, we want the mean for each of the gender dot mean. So this is the mean score for male, 348. The mean score for female is 389. So that is also how to make use of the group by objects. So the one more thing we've talked about this three. Then today, majorly basically what we want to discuss today is how to make use of different visualization plots for your data analytic projects. Firstly, before we talk about that, we should talk about variable, because knowing the kind of variable you are dealing with, it will make you may know the appropriate visualization type to use for your data frame. Basically, we have two types of variables. We have numerical variables, we have categorical variable. For numerical variable, those are the number variable, for example, salary, then the number of children, the number of house. Then for the numerical variable is also known as quantitative variable. They can be quantified. Then we have two types of it. We have the continuous variable, we have the discrete variable. Continuous variable are the ones that are like it is possible for you to have, I think, decimal something. Then but the discrete, you can't, for example, continuous variable you can have 0.5, you can have 1.5. But for the discrete is either 1, 2, or 3. There's nothing like, for example, you want to talk about number of children someone has. You cannot say the number of children is 3.4. That's not possible. Either 3, 4, or 5. That's discrete. Then for the continuous, for example, we can talk about salary, school fees. Those are continuous data type. Can anyone give us any example of either continuous or discrete data type?
As in terms of what you already mentioned them.
Any like other examples? Any person?
We have like age. I think age is a discrete data type.
Yeah, age is discrete. You cannot say you are 25.2 years old. It's either you are 25 or 26 or 24. Thank you.
And then like GPA may be continuous, it may be discrete. But in most cases,
GPA is continuous because there's always points.
Yeah.
Right?
Yes.
So about categorical variable, they are also known as qualitative variable. They are in category. They are not in number. For example, when we are talking about gender, either you are a male or female. And let's say the class either you are in part 1, part 2, or we are talking about your department. You are in microbiology, you are in collective intelligence, you are computer science. Those are categorical variable. Then under that categorical variable, we have two distinct types, the ordinal and the nominal. Can anyone explain the difference between the two, the ordinal and the nominal data type? Hello?
Yeah, okay.
Anyone? So when ordinal is when the order of the variable, when the order matters, but nominal is when the order doesn't matter. Let me give an example. For example, we are talking about students. Then we have the student data set, we have the department, we have their CGPA, then we have their position, we have first position, second position, third. Definitely, so you cannot say that someone that is in the first position and someone in the second position, you cannot say they are the same, that there's no difference between them. Can we say that?
No.
But if, for example, male and female, we can, for example, you cannot say male is better than female or female is better than male when you are talking about the student data set. But when you see someone in the first position, you see another one in the second position. By default, we know who is better, we know who is best, right?
Yeah.
So that's the difference between ordinal and nominal. Ordinal is when the order of the data, when the order matters. Nominal is when the order doesn't matter. For example, you are talking about departments. You are in microbiology, someone in biochemistry can be better than you, can ask good grade than you, can have good grade than you. Then, but when you see first position, second position, that one is ordinal. We know that the first position is always the best. So that dealing with it will make you know the appropriate visualization to use for your data. So we'll be moving to data visualizations.
So please, can you state the difference between the ordinal and the nominal? Well, please, I didn't really get it, please.
Okay, the ordinal is when the order of the variable, when the order matters. But the nominal, when the order doesn't matter. For example, we have male and female gender. By mere looking at the gender, you cannot say which one is better, which one has the highest CGPA, which one is the best student, by mere looking at the gender. But by mere looking at the position, you know that, oh, this is the best student in the class, the person that comes first in the class. You get it?
Yeah.
So that's the difference. So we have different visualization libraries in Python. By default, there's a pandas for, you can use Panda. Panda we've been using since. We can also use it for visualization. Then we have matplotlib, then we have seaborn. Then the different kind of back of the chart we have is the bar chart. Then we have the histogram, we have the distribution plot, we have the count plot, we have the volume plots, then we have subplots, we have how to label your plot. So I'll be starting with the pandas plot. This is gender. I want to plot, let me cut this out. So I want to see the number of male and the female we have now for our gender. So since I've changed the gender from uppercase to lowercase, I need to change this to lowercase gender. So we have 15 male, then 11 females. So I can do a plot. Then I want to plot the kind dot plot is I'm plotting. Then the kind of plot is what? The kind of plot is I need a bar plot. You can see this is a bar plot. This is male 15. Then this is female 11. Then we can change this to something else, like a pie chart. Instead of having a kind, then we make this pi, PIE. We can see that the percentage of male then female. Can we see that? So this looks better. We can see by this chart that we have more males in our data set than female, right? For example, this type of data is categorical data. It will not be okay if you are plotting score in a pie chart. Let's try that with math. We need to change this to lowercase. And if you even check the value count, we see that we have many values that might not stand well on a pie chart. You can see the different values we have: 9, 3, 2, 2, 1. Why do you have 3? I don't understand. Okay, we have 100. We have 100 9 times. We have 75 3 times. Actually, we can make use of a pie chart for this as well, for the score. But it's not the best representation of the score. We can see 100, 75, 80. We can see that, right? But that's not a good representation of the data. The best is making use of a distribution plot to check the distribution of our data of the math score. So I'm making use of East now. East is like an histogram plot. You can see that. We see that majority of the students, what's this? You have 9. These are the values. Then 100. What's this? Let me check the math score. Why do we 70, 80? Oh, I'm not supposed to use the value count. So I'm just supposed to plot it directly. The value count is plotting this for me. This is what the value count was plotting for me. It is plotting 9, 3. It is saying that I have 900 times. So this is it. But I don't need the value count. I just need the distribution of the math score. You can see this is the distribution of the math score. Majority of the students, they score around 100. So this is the number of people that score 100, then followed by this 80, 90. Then we can see that from this place, let's say from 10 to like 40, we don't have any score there. Then we have a very few people scoring 0, like between 0 and 10% and 10. So we can do this for other subjects as well, Greek. And dot plots. Let's see if we can change this to this distribution plots. So we cannot make use of distribution plots here. You can as well make use of a bar plot as well. This is it for Greek. Then another thing, we can make use of a box plots. Box plots. So this is how to interpret a box plot. The middle one is known as the median. This is the median, or you have the first quartile, the second quartile, and the interquartile. This is the third quartile. Yeah, this is the third quartile. The third quartile is also known as the median, like the median value. Then we have the minimum value is here. Then we have the first quartile. This first quartile is when we check our df dot describe. Df dot describe is our 25 percentile for Greek. Let me transpose the data. So this is it. For Greek, we have the mean 62. Then our median is 50, which is 67.25. This is it, the median. Then we have the minimum value for Greek is 14.5. This is the 14.5 is around here. Then we have the interquartile, the third quartile, which is also known as the median. That's 50, 67.25. Then we have the third quartile. The third quartile is also known as the 75 percentile, which is the 79.50. This is 79.50. Then we have the maximum value to be 100. This is the maximum value 100. Sometimes we will see some value outside of this. Those ones are called outliers. Let's check if we see outliers in our data set. And another parameter you can include here is the fixed size. You can try to increase or decrease the fixed size. Fixed size is the figure. Okay, it's not bringing out the figure parameter. We can't apply it here. So that's the interpretation of a box plot. Let's try with another variable. Let's see if we can get some outliers. Let's check mathematics. Okay, we can see this one. We can see this data point standing alone around this place. We can see that.
Yes.
That's the outlier. The minimum value is this. Then this is the second quartile. This is the third quartile. Then the fourth quartile, which is the 75 percentile, and it is also our maximum value. So let's check for math. We have the minimum value to be 0. You can see that, but it doesn't go well with others, which means that it is very far from the next value. After 0, the next lowest value we have is around 40 something. So this 0, it takes it as an outlier. That's why the point is far from the other. Let's check with another variable.
What actually do you mean by outliers?
Outlier is like a data point that doesn't conform with others. For example, let's say we have score from 1 to 100, then we find out that all other students, their score is from 40, 50, 60, 70, 80, 90. But we find out just a single student is scoring 0%. That's like an outlier.
Okay.
Probably that student doesn't, like the student did not write the particular exam, so they gave the student 0. Or the student just did poor, like did bad in the test. So it's an outlier that doesn't conform with other data points.
Okay.
Is that fine?
Yeah.
So let's check with
Another
English.
thing I would like to ask you, please. Where this df dot described.
Yes.
Why do you put T in front of that?
If I don't put T, this column mean marks, all of them from that place to this place, they will be by this side. The transpose is like I just divert, I put what I have in my row, I put it in the column. What I'm supposed to have in my column, I put it in my row. Let me remove the T now. You can see the count me median here, then the math, English, biology here. Then if I do the transpose, we bring this everything here, the math, English, it will bring it to my rows here.
Okay, so
I do it most time when, let's say I have something that is the data, the column, there are very many. It extends from there to the end of the screen here. Then there are still some of them inside. Instead of scrolling up and down, if I use the transpose, I will just scroll like this. Is that clear? We can see for English now, we have an outlier here, but we have the median value, we have the maximum value. We can see the distance between the minimum value and the second quartile. Then we can see that the third quartile, which is the 75 percentile, is very close to the maximum value. We can see that here from the describe as well for English. You see the 75 quartile is 97.5, then the maximum value is 100. They are so close. You can see that here, right? So that's box plots. So another thing we can try is scatter plots. Scatter. I'm not sure scatter plot is going to work here because we need to make use of two variables. So it's not going to work. So the scatter plot is not going to work. Another thing we can do is to have a line plot. A line plot is a kind of scatter plot actually. So I plot the whole data frame now. This is this is representing my total score. My total score is from 400. Then like this, I'm supposed to even remove the total score. So that because the unit for the total score is like 100, 200, 300, 400, whereas for the unit for the subject, they are just from 0 to 100. So to make it look more okay, I need to remove the total score, df dot drop total. Then I need to put the axis equals to 1. Then after dropping it, I can now have my plot. You can see now the value now, the unit is from 0 to 100, unlike what we had before from 0 to like 400, 500. So this particular one, this is the English score. The first, we have a few people, like let's say one person scoring 100, then we have another person around 0, then we have the next value here, the next value here, the next value here. So this is the graphical representation of the score. We can see that they are not actually, they don't follow a particular pattern, unlike this last one, the intelligence. It's like, it looks more like a straight line. I should remove that as well, because the scale is from 1 to 9. So to remove that, I just need to put a list of column that I don't need. So instead of having one, I have 2 columns that I want to remove. So I have it here. So basically, those are the Pandas plots. So there are more beautiful libraries we can use for visualization. They are matplotlib and seaborn. So I'll be using import matplotlib .pyplot as I'm importing it as PLT. Can anyone tell me the relationship between this pyplot and the matplotlib? Hello.
The pyplot is a sub function of the matplot.
Exactly.
It's inside the matplot.
But inside matplotlib, we just need this pyplot. It's a module under the matplotlib package. So I import the module matplotlib.pyplot as PLT. This PLT is just an alias. Then we have a more advanced visualization library in Python, which is seaborn. This is like the best of them all. It's a visualization library. You can use it to do a lot of things. This seaborn is built upon matplotlib, just as we have pandas built upon NumPy. We have pandas built upon NumPy. Our visualization. So there are some other things to include. You can say percentage matplotlib inline. Then import seaborn as SNS. Then we can say sns.setStyle. Set_style. And we can use dark grid. You shouldn't worry about this. Let me try to explain this first line. The first line here, I import the matplotlib as PLT. Then the third one here, I import the seaborn as SNS. This matplotlib equals to inline. In the previous version of Python, if you run a code like this, let me try to run one now. df.gender. That's PLT. Plots. PLT.plot. df.gender. PLT. Let me use a count plot. I don't have count plots. Okay, I don't have count plots. What about bar plots? LT.bar. Okay, I have a bar plot. Then I need to specify df.gender. Let me use distribution plots. Does this? Okay. Math. I don't need X or Y for this one. Okay, this is it. Previously, in the previous version of matplotlib, if you don't put matplotlib in line, you need to put plt.show before you can see the plots. But with the current version, you don't need to put it there. But because this Jupyter notebook is very interactive, it automatically dictates that this is a plot that needs to be shown on the screen. That's why we have it here. In the previous version, or when you are using IDE, let's say maybe you are using PyCharm or VS Code, you need to either specify plt.show at the end of every plot, or when you are importing your matplotlib, you declare this inline. Inline means to be shown immediately after you put in the code. So another thing for the SNS.setStyle, this is just like a style. For example, we want our plot to be, let me try to comment it out. And let's run this code. SNS. What should I plot? Is plot. Then I put df.math. You can see how it looks. Can you see that? So let me try to put in the SNS, the dark grid, and run it again. You can see that something has changed. Hello? Hello? Are we following, please?
I can hear you.
Yes.
What I just did now, you understand what I just did? So that's the function of just this style. We are just trying to set up a style to give our chart a background. So I can change this to white grid instead of dark grid. And there are a lot of other styles we can use. You see this, we just have just white, but I think the dark grid is better, right? The dark grid is better. So that's the SNS. So from now on, we will be making use of the SNS. So all we've plotted initially, we can plot them all again. Matplotlib. So let's start with df dot. Okay, there is something I should talk about. df.col. df.col is to check the correlation between the different variables we have. This is the correlation. We have some correlation that can be positively correlated. We have some that can be negatively correlated. For example, we can see that this is mathematics and mathematics 100% correlation. That's why we have 1. Everything we have in the middle here will be 1 because we have 100% correlation. Total and total we always correlate. So we have the total and math. We have 0.5% correlation between total score and the math. Then we have 0.4 correlation between English and total. Then we have 0.47 between biology and. But if you check this, we have agric. Between agric and let's talk about the level of intelligence. We have 0.89 correlation between agriculture, agric as a subject, and the level of intelligence. Whereas for economics, we have 0.5. For others, we have 0.3, 0.1. What this is telling us is that it is likely for someone that scores higher in agric to have higher level of intelligence compared to other scores. So that's what the correlation plot is telling us. We can put this into a plot. A visualization. Let me try and do that. So we can put this into a plot of what we just do, sns.heatmap, then df.correlation. So this is, we can see the ranges from 0 to 1. 1 is those that are highly correlated. We can see this math. The diagonal line we have, the diagonal line at the middle here, this 1, 1, 1, 1, 1. This is the same thing we have here. So they are 100% correlated. We have those that are not so correlated. We have this dark column, that's 0 correlation. Then we have some that are light. For example, you can see that intelligence and agric here, they are somewhat correlated. Then we have intelligence and total score, so they are correlated. If you are intelligent, it is likely that you are going to have a very high score. So that's that about the heatmap plot. Then there are a lot of other things other type of plot we can make in Python using the seaborn. We can start with df.gender, then dot. I like this SNS. It's very simple. Just do SNS dot. When you put dot, just press tab. You will see various type of plots you can have. You can have histogram plots, we can have bar plots, we can have boxing plots, you can have box plots, you can have cat plots, you can have cant plots. Let's start with cant plots. Cant plots. And cant plots. By default, this one, it requires only one argument, which is x. What do we want to cant? We want to cant gender. There are 2 ways to do this. You can do it directly, df.gender. Then you run the code. You can see that look at this male, female, we have 15. Female, compare it to what we have with our pandas plot. This is the panda plot. Which one do you like most? Hello? Hello? You guys are not following.
I'm with you.
I showed you the 2 different plots now. Which one do you prefer most? This is the
All of
pandas
them are the same.
This is the Pandas plot for the male and female gender. Then we have the seaborn plot for male and female gender. This is the seaborn plot for male and female gender.
The seaborn is
Which one do you like most?
The seaborn is more
Okay, the seaborn. Most time when you run your code, we see a bunch of texts that you don't understand, something like this. So one way to get rid of it is just put this semicolon at the end of your code. If you have 10 lines of the code, put it at the end of the 10th line. Just run your code. Everything will disappear. You can see that. Okay, you still have it. So this is warning. It's different from the bunch of code. There is a way to remove the warning in our next I'll be talking about that. So another thing you can do, I have this plot BF gender. Then another way I can do it is not using this BF gender trait. I'll put gender as a variable. Then I will specify the data I'm using. Data equals to, and the data will be DF. You can see that. So this, I have the same plots, but different syntax for the same plot. Another thing we can do is to SNS dot. We can use bar plot as well. This is bar plot. We can use cant plots. Okay, that's cant plots. We can use bar plots now. Bar plots. Then we want to plot gender against intelligence. I will specify my x equals to gender, y equals to intelligence. Then I will specify my data equals to df. This is the standard way of doing it, the most basic way of doing it. So this is, I plot my gender against intelligence. My gender on the x-axis, the level of intelligence on the y-axis. By default, I can get the same plot by using this. I don't need to put x equals to. By default, anything I enter first will be taken as my x-axis. Then the next one will be taken as my y-axis. And I need to specify the kind of data frame I'm using. You can see that I have the gender, male and female, the same plots. Can we see that?
Yes.
Another thing to do is to do it this way. My x-axis, I want it to be df.gender. Then my y-axis, df.intelligence. This one, I don't need to specify the data frame again because I already attached df to each of the variable. Because df is my data frame. You can see I still have my plots. So another thing to do is you can delete this and put it as string data frame. Then the same thing with this. You're still going to have the same result. So those are different ways of getting your plots. So another plot we can just try out is SNS.boxplots. Let's check the box plots now. We can actually plot our data frame together. The box plots. It's going to give us the box plots of all the numerical variables in our data frame. You can see that we have the mathematics, we have English, we have biology, we have economics, we have agriculture. I want to remove total and intelligence. I need to remove those two because they are different from others. Others, they are just from 100 to 0 to 100, but those two, their scale is different. So I need to remove those two. I need to drop them, then have my plots. df.drop. Axis equals to 1. And box plot. You can see that the box plot, they are looking better than what I had initially because of the scale. The scale for the score is from 100 from 0 to 100. But when I added the intelligence and the score, it's increased the scale from 0 to like 500. So these are the same data type. Another thing I can do, if I want to increase this, I need to put plt.figure. plt.figure. Then I specify the fig size. size is the size of my figure. You can change it to anything you like. Let's try 12 by 6. You can try changing it until you have the most. We can see that this one is bigger than what we have before. Then you can, I think 12 is representing the width of the plot. Then the 6 is representing the length of the plot. Let's change 12 by 12. You can see that this is very long. So the 6 is fine for this one. And you can make this one like 16. So we see that this looks better now. We can conclude that, okay, on the average, a lot of people score better in mathematics, followed by English, followed by biology, then this. So generally, people did very well in Agric because the plot looks normally distributed, like the distance between each one of the different quartiles, the difference is almost the same thing. So those are some of the conclusions we can make. Then another thing, we can try to beautify our plot. We can say plt.title. Then we can say box plot. The title of our plot will be box plot for 5 subjects. 5 subjects. Then we can name our x-axis plt.xlabel. This is what I just wrote now. The box plot for the 5 subjects, that's the title. Then on our x, we can say subjects. Subjects. You can see we now have the subject as our x label. Then we can give this label y label, our y axis. We can give it a label as well. What label should we give the y axis? plt.y label.
Scores.
Exactly. We should call it scores. You can see we have our score on the y-axis now. Hello.
Yeah, we can see it, sir.
So those are a few of the plots that we can carry out in Python. There are a lot of other things we can do. We can try and I've talked about how to use fixed size. Fixed size is to increase or decrease the size of your visualization of your plots. Then we can talk about what else? Let's try fouling plots, SNS dots, cat plots. Then df.math, df.gender. This is a categorical plot. Let's see how it looks. Has null object length. Okay, let's go with math. Okay, this is not working as well. Let's use fouling plots. Fouling plot is like a box plot, but it gives more interpretation to our data sets. This is telling us that, for example, I think there is someone that has a score of -20. I don't know how that happens. And another one person with 120. Is that possible? I don't think so. Let's make use of another subject. Okay, the same thing. I think this has to be my y-axis. Oh, yes, I should have gender on my x-axis.
Sorry, please, can you interpret this plot?
I will interpret it.
Okay, thank you.
My y-axis is, then my x-axis should be gender. X equals to df.gender. So this is the male, this is the female. This is telling us that majority of the people, they score between 60 and 80 for the male gender. Then we have a few people scoring like 120 above, then few people scoring 100. But the median score is still around 60. Whereas for the female, majority of them, there are a lot of people that score between this 40 and 80 for both sides. Then the highest of their score is not up to 120 like the male. the highest score is around 120. It's not up to like 140. And on the average, like their score, the lowest score for female is far. The lowest score for female is greater than the male. For example, we have the score for female starts from, let's say, 0. But for the male, we have people that score minus 20. I think there is an issue with the data set somewhere. We shouldn't have minus 20. Let me try to check. They're not supposed to have this minus 20, but that's basically the interpretation of the plot. There are a lot of people scoring between this 40 and 80 for the female gender. Whereas for the male gender, we have one here, 60 to 80. Then a few people are scoring 20. Then we have the highest score, about 140 here. Whereas the highest score for female is 120. Then the lowest score for female is 0, but the lowest score for male is minus 20, which means the male gender, they have the least score, the lowest score, and they also have the highest score. But on the average, the female, they are actually doing better than the male because many people are scoring a very good mark below the median value. So that's the interpretation of this plot. There are many other plots we can carry out. SNS dots. Let's check for other plots. Okay, there is this plot, distribution plots. This plot. Then we put in. Let's check the total score. Then data equals to df. What other way can I have the same syntax? What other way can I write it? In what other way can I write it?
df.total.
Data equals to, how many parameters should I include in this? Let me check. Most time when you don't know what parameter to include, just press Shift Tab. If you press Shift Tab, you will see this. So by default, I only need to input.
On my system, doesn't show me all this.
I need to put only one parameter. So let me just go with df.total. Distribution plot for my total score. We can see the distribution. This is like combining histogram list plots and df.total. You can see this histogram. That's the same thing we have here. But the only difference with the distribution plot is this plot is showing us the distribution with this line. You can see the line on it. It is telling us that it looks normally distributed. Let's check with another score. Let's say math. I know math can never be normally distributed. We can see the distribution now. This one is skewed to the left. Can we see that?
Yes.
We can see it here too. It is skewed to the left. So these are a few things, few of the visualization we can carry out. There are many of them actually. There are a lot of them. So these are just few of the visualization. From this, you can make conclusion, and they look more presentable than just writing code. Showing people that okay, this is the number of female we have compared to this to male is better than just showing df.gender.value counts. This look more beautiful, right? So I think this is let's check our outline. If you have any question, this is a very good time to ask.
I have a question. The first part you did when the last part we were supposed to do, as in the last session. So before this visualization, I have a question. The time when you are trying to change the columns name, can we like make it a double assigning a multiple variable on a single line. Instead of changing the name like math to math, this to this to this, then we name all the old columns. Then subsequently,
And we have a new column, right?
yes.
Then the new column will bear the new name we want to change to.
I understand. What I'm trying to say is that the way you did it, can we still do it like assigning a double variable on a single line?
I don't get the question. Can you call it for me so that I type it straight?
Okay, just list when you list the name of you list the old names.
Yeah, the columns. Yeah,
Then
these
you
are the
list.
names of.
Then you list the old names.
This is the old name.
Yes, actually. Now, after listing the old names, after listing the old names, then you put the semicolon.
Okay, like this. Are you talking about this?
That's what I'm saying. But you know, here you put first name in front, right?
Yes.
As in changing it to the new name. What I'm now saying is that you list all the old names, Then in front you put semicolon and list the new names.
No. It can't work like that because I'm using a dictionary. A dictionary, it's as we've done before, it takes in a key value pair. To each key, the value must follow it immediately. I understand your question. Like we first list the old names, then we put in the new names, right?
Yes.
One thing we can do is another thing we can do is to do it this way. df dot columns equals to, this is the order of the column.
Yes.
You can say df dot column equals to this. Then you put everything in a list. Let's try with this. You see this now? Hello?
Yes.
This will change all the columns. This will change all the columns from this lowercase to uppercase because they follow the same order. The reason why I did this is that we are changing everything. Actually, when we are changing everything, we don't need to write first name, then first name, last name. We just write the new names since they are in the order we want them. But this is just to be very sure that you are actually changing the right column to what you want. For example, maybe in your column you have the last name first, then you now put first name first. It's going to interchange. This one is just to make sure that they are in the right order. You can do it this way as well. Let's try this. Okay, you should have one closing column. Do you see that?
Yes.
Let's check our DF now. You see that it has changed to what we had before.
Yeah.
So you can do it both ways.
Okay.
Yeah, you can
Thank
do it both ways. You're welcome. Any other question, please?
Yeah, I wanted to ask about the outliers. Sometimes when you are doing data cleaning,
Yes.
I think sometimes you're asked to remove the outliers and maybe some missing values. How do you remove the outliers?
Actually, you can. There are some outliers that you shouldn't remove. For example, let's say you are dealing with health insurance data. Then you find out that majority of the people, they charge them from, let's say, 10,000 to 100,000. You get? Then you now find someone spending 10 million. Definitely that's an outlier, right?
Yes.
But when you check through the data set of that person, you find out that the person has carried out like 5 operations, surgeries. With that, can you still say it's an outlier?
No.
Yeah, it might look like an outlier, but at that particular instance, it's no more an outlier because you can actually account for the spending. You get? So that shouldn't be removed. One thing you can do is to standardize the column so that the value doesn't affect the data. especially when you are working on a machine learning model. The thing, one you can remove, for example, let's say you are working on the student data set, then you have age. These are the undergraduate students, so you are having someone of age, let's say 105. Is that possible, undergraduates? Can you hear me?
Well, I can hear you. I don't know what a
You say,
grammar would
well,
mean.
have you seen it before?
I've not.
So that definitely is an outlier. Undergraduate age 108, that's an outlier. You should make it. There are two things you can do. You can remove the particular column, or you equate that particular age to the maximum age you have. Like, for example, let's say the maximum age you have is 35. Then you make the one on 108, you bring it down to 35, or you remove it totally. You get?
Yes, sir.
So those are the things you can do on it. Do you have any other question? So the class is meant to be for 8 weeks. If we, by my counting, we did 12 classes before. That's 12 divided by 2. That's 6 weeks already. So this week is going to make the 7th week. So we are still, I think we are still on schedule somehow. So I think we've done majority of what I have in plan. Data cleaning, we did data cleaning, we did data visualization, we talked about scatter plots. Oh, let me do one scatter plots. Scatter plot is just to see the distribution of, for example, let's see the distribution of age. Let's check the distribution of age with SNS scatter plots. Scatter. If you don't know what to plot, just once you press the dot, just press the tab key. You will see different options. Then if you press SC, you will see the option changing. Then you can press tab to enter it. Someone was saying that she couldn't find it on her own laptop. Is that right?
Yeah, it doesn't work for me.
Is it on Collab or Jupyter Notebook?
Jupyter Notebook.
It works. I have my Jupyter Notebook on. Let me just try and see if it is still active. I have my Jupyter Notebook active. I have it on. But in Collab, if it is not showing, this is what you should do. Go to Tools, then Settings. Then go to Editor Setting. Then make sure that every other thing here is checked, except the first one. Automatically trigger code completion. Every other thing is checked except that first one. Then you save. By default, you will be seeing it. It will be doing auto completion for you. Then for the Jupyter Notebook, let me see if I can. Okay, let me try and open a new file here. So okay, let me continue with my scatter plot. Before you can plot a scatter plot, okay, you should have your X and Y axis, and the two of them must be numerical variable, because you are trying to, let's try to compare mathematics score and English score. Math, that's our X axis. Then on our Y axis, by default, anything you enter first will be on your X axis. Then anything you enter second will be on your X axis. But English, then you need to specify your data frame. Data equals to df. So the scatter plot is just like the correlation plot. It tells us the relationship between we can see that the mathematics and English, they don't have any correlation at all. You see, as they are indeed scattered. Can you see that? You can't pinpoint any relationship between the two of them, right? No.
Yes.
So let's check intelligence and agric. Intelligence and agric as a subject. We can see a kind of positive correlation here. Like the higher the score in agric, the higher the level of intelligence. Can we see that? So that's scatter plot. We are dealing with categorical variable. Categorical. You can use count plots. Count plots, pie charts, bar plots. Then for numerical, you can use ist plots, histogram. You can use dist plots to check the distribution. Dist plots. You can use box plots. Then what else? You can also use bar plot as well. bar plots, then scatter plots. But when you are making use of bar plot and scatter plot, for these two, you need to include two parameters, your x and y axis. But for the others, you can just use only one axis. So for you can use line plot for these two. You can use line plots for your numerical variable, line plots. SNS.line, line plot, then math, bf.math. We want to check the line, how it goes. Why is it not showing? What's happening? Okay, one more thing. We spend more than 1 hour actually. Okay, we can actually stop here. So our next class is going to be more of working on a data set from the beginning to the end, the normal approach. When you have a data set, how you should approach such a data set, what you are expected to do, the conclusion you should derive from the data sets. So that's what will be our next class. Then that's tomorrow. Then next week we'll be concluding with a career session, how to tailor your CV, resume, then how to put your work out. So I think we've covered most of the things we have in the outline. At least we did the menu app for restaurants, we have the weight converter, we have the BMI calculator, then the data visualization. So I have one project for us now, another project. I believe it's something we can do. For those of you that have not submitted your first projects, tomorrow is the deadline. So this is the second project. The data set has been uploaded. I have it here. What's happening? Is my kernel dead? Just Python projects too. So this is the second project. This here is the data set. This is the data set, store data.csv. One thing you can do is to click on the data set. Then from there, you click on raw. You click on this raw. Then you copy the link straight. This is how the data looks like from 2014 to 2018. It's a data set for a supermarket, for a store. So the first question here is, this is the link to the data set. You can copy it directly. So the first thing you need to import your libraries. You import your Python, Pandas, NumPy, the matplotlib, the seaborn. If you like, you can set a particular style. You can set style for your data frame. Then the first question, which store has the highest total sales for the final month? The final, let me show you how the data looks like. So this is the data set. This is the first month. The first month this is May 2014. Then we have 4 weeks. 1, 2, 3, 4. If you want to check for the first month, you'll be checking for this 1, 2, 3, 4. So that's how you check. For the final month, you come to the bottom of the table. So this is the final month. The final month is 2018 February. Then we have this February 2018. We have 4 weeks. 1, 2, 3, 4. So what you are expected to do here is to sum up what you're expected to do is to sum up the sales for each of the stores for the last 4 months. So that's what you're expected to do here. And remember, when you are working on what we do is to select the data you want to work on, then you do the sum. Then after that, if you can write, okay, maybe store A has the highest total sales for the final month. Final month is the last 4 weeks. Then the second, if you can do it, provide the visualization for your plot, for your answer. You know, that will be a kind of categorical data. So you can provide a pie chart, a bar plot, a cant plot, or any plot that shows your answer. Then the next thing, which store makes the most sales on average? What you need to do is just df.describe. When you do df.describe, Then you will see the mean, the median, the mode for each of the store. So on average, you will check the store that has the highest mean, highest average. So the third one, which store sells most during the week of March 11, 2016. This one you have to subset. You subset your data, something like this. 2016, 13, no, 03. Then 13. So this is how you subset your data, like we did for the male gender. So you subset that DF, for example, you can say DF, then DF, date, where date, DF date equals to X, you say week, then equals to this. So you put this in, because this is a string, you put it in string. Then when you subset this, then you can now find the sum. You don't even need to find the sum because this is just a particular week. Then after, if you subset it, you can find out the store with the highest sale. Then the next thing, in what week does C makes its worst sales? What you need to do is df dot minimum will give you the minimum value. Then you trace the week. You give us the date like this, maybe the March 13, 2016. So that's what you do. For the final answer, final question, what was the final question? Which store has the most sales in the last 3 months period? The last 3 months period is last 3 months period. Which store has the most sales in the last 3 months period? So what you need to do is to come here. The last 3 months we have February, January, and December. You are going to start from here. From December, you will subset from here to here. Another thing you can do is to use df.tail. Then you count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, like 13. df.tail, then you put 13 or 12 in the brackets. Then you work on those 12 data points. That's the last 3 months. So I'm going to push this one to the GitHub repository right now. Is that something we can do, please? Hello?
You can try.
We can figure it out. If you have any questions, we can answer.
I'm sorry, the class is taking longer than expected. Let me just push this to GitHub and we finish the class. There's no other question, right?
Not for me.
So I'm going to stop recording the class now, then we can just leave the class and fill our attendance sheets. All right, bye-bye.
Thank you. What's the deadline for this other assignment?
This will be next week.
Okay, then the first project is tomorrow.
The next week will be Friday, before the next class.
Okay.
So we can leave the class now. We've come to the end of the class. So someone was asking about not seeing those options in collab. Is the person still on the call, please?